Okay, so we're doing chapter 9, problem 93. So this is says consider the problem from a railroad car problem from 992, the problem right before this, where we have a open railroad car coasting along with constant speed and snow's falling and filling up the car as it goes. Okay, so part A here says determine the speed of the car as a function of time using equations 19. Okay, so the equation here gives us our total mass times the rate of change velocity equals the external force plus relative velocity times dm dt. Okay. So from this, we know that the added mass is in the opposite of the horizontal velocity of the moving mass since the added mass is moving straight down. So we know that m dv dt is equal to negative v dm dt. From this, we can do separation of variables. dv equals dv over v, equals negative dm over m. And what this implies, if we integrate this, we get the integral from v naught to v final dv over v equals negative integral of m naught to m final dm over m. So the integral of 1 over x is log, natural log, so this becomes natural log of vf over v initial equals negative natural log of the final mass over the initial mass. Okay. Well, and that's equal, we can put the minus sign in here and that flips the arguments here, so we get negative initial mass over the final. And then we can solve for what the final mass here and see that the final mass is equal to, or final speed is equal to the initial speed times the initial mass over initial mass plus dm dt times t. There we have the final speed as a function of time. Okay, part B now says, what is the speed of the car after 60 minutes, and does this agree with the simpler calculation? Okay, so now v as a time equals 60 minutes. We can just take the initial speed here, which was given, there we go, 8.6 meters per second times the initial mass was 4,800 kilograms. And then we have 4,800 kilograms plus the final mass, or the mass accumulated, was 3.8 kilograms per minute times 60 minutes. And this comes out to being 8.2 meters per second, which if you go back and look at problem 92, it does pretty much agree with. So